So I'm going to be going over what light is. In order to do that, I want to talk a little bit about how we originally thought, or what we originally thought light was. To do that, we have to go back to ancient Greek times. Now, their idea of light was very different from ours. They actually thought it was a form of matter, but that it actually was emitted from our eyes. And when we closed our eyes, that explained why we couldn't see, because matter wasn't coming from them. This, however, doesn't explain why at night, when our eyes are open, it's still dark out. So we had to kind of change or update our idea of what light was. So recently, light is known more as one of the 7 fundamental forms of energy. Actually, it's known as radiant energy. Light also does not require a medium for its energy to be transferred. Now, a medium is basically just a substance that makes the transfer of energy possible from one location to another. If we think of electricity transferring from, for example, the wall to a lamp, the medium in that case would have been the electrical wire. Well, light doesn't require a medium to transfer from point A to point B. Light is also referred to or considered to be an electromagnetic wave. What that means is it's actually 2 waves put together. One wave being electrical and one wave being magnetic, and they actually oscillate perpendicularly. Light also travels at, well, the speed of light. It's the fastest known traveling substance that we know. It's defined as a constant. It's given the little letter C for the standard international units, and is defined as 3.0 times 10 to the 10 centimeters per second, or 3.0 times 10 to the 8 meters per second. And that would be the speed of light in a vacuum with nothing else around. Now, as I mentioned, light is considered an electromagnetic wave. So let's look at parts of a wave. If we look at the top of our wave, we call that the crest. The height of the wave is actually measured from kind of this middle point to the top of the crest, and that's referred to as the amplitude. And the bottom of our wave or oscillation is referred to as a trough. Now, we have this kind of imaginary line in the middle where this wave is oscillating around, and that line is actually referred to as the line of rest. And anywhere where the wave actually crosses the line of rest, we call that a node. Now, there's a few other terms that are pretty important when talking about waves that I want to cover. The first one is wavelength. So wavelength is given the Greek symbol or letter lambda, which is kind of like an upside down Y. And wavelength refers to the distance that one full oscillation occurs in. So here's a full crest and a full trough, and therefore that would be the one wavelength of this wave. Now, another easy way to measure wavelength is to go from the very top of this crest to the very top of this crest. Either way, you're getting one full oscillation, and that is the wavelength of a wave. The second important term that I want to talk about when dealing with waves is frequency. Frequency is the number of wavelengths that occur over a certain distance. So again, if we look at this wave, we have a certain distance here, and if I look at this whole distance and count the oscillations, I would get 1.5 wavelengths. And I consider that a fairly low frequency, especially if we compared it to this wave, which is covering the same distance of space, but here we're getting more oscillations. In fact, we're getting a frequency of 3 wavelengths in that same area. So this wave has a higher frequency than this wave. Now, the other thing that I want to point out is that wavelength is actually inversely related to frequency. So if we look at the wavelength of this first wave, we get a rather long wavelength, even though we had a low frequency. And over here, and we look at this wavelength, it's actually a very short wavelength, even though we had a high frequency. The last thing that I want to talk about when dealing about wavelength and frequency is the smaller the wavelength, the more energy that a wave has. Now, as I mentioned before, light is part of an electromagnetic wave. And there's more to light than just visible light. It's actually called the electromagnetic spectrum. And that includes all the different types of light that we have. So here is the whole electromagnetic spectrum. Down on this end, we have very long wavelengths, starting with radio waves, moving to microwaves, and then moving to infrared light. And then we get this tiny little portion of the electromagnetic spectrum that is actually the visible light that we think of when we think of light. And we know we can actually separate visible light into, well, the colors of the rainbow. After visible light, we move into ultraviolet light, X-rays, and finally gamma rays. And if we look at the frequency of these waves, we have very short wavelengths at this end. Now, one way to remember kind of the order of these, because you are going to have to know the order of these, especially around visible light, infrared light has red in its name, and it goes into visible light, which starts with the lowest frequency of red. And then visible light ends in violet, and the next type of electromagnetic light in the spectrum is ultraviolet light, and it has violet in its name. Again, if we look over here, we have those long wavelengths, which means that it has a low frequency, and these are the low energy waves of the electromagnetic spectrum. And up here with those really short wavelengths, we are getting the high frequency of waves, and that means that gamma rays have the highest energy of waves. Now, if you look at the chart that you have to fill in from your notes, you can use the chart on page 466 to fill in all different applications or uses of each of these different types of light. And you'll notice they give you the frequencies of all these different ones, and you can see the difference between the low frequency in radio waves and the high frequency in gamma rays.